And then we have a given condition that at temperature 175 degrees, the gas occupies 100 cubic meters. So the gas occupies 100 cubic meters, and meaning that's the volume that it is able to occupy with this temperature. Now this will help us to solve for K, which is the concept of proportionality. So from our initial function where V is equal to K times T, so when V is 100, then you have our T equals 175. Okay? So our K is 100 over 175, or to simplify, that's 4 over 7. Okay? So that when we go back to our function, you have V as a function of T, function f of T, that is equal to K, which is 4 over 7 times T. So this is now our modeled function. Okay, as stated in the problem. Okay, now the next question is, what is the volume of the gas at a temperature of, okay, so this is B, this is A, okay, at a certain temperature 140 degrees, the volume is being asked, so we could just easily use the modeled function. So our volume therefore is equal to 4 over 7 and times T, which is 140. Okay, so that will be equal to 80. Okay, so since in the problem, okay, the unit for volume is cubic meters and the unit for temperature is degrees, and therefore the volume here is 80 cubic meters. Okay, next example. Okay, for our next example, we have, in a forest, a predator feeds on prey, and for the first 15 weeks since the end of the hunting season, the predator population is a function f of x. Okay, so we have here one of the quantities is the predator population. Okay, then let's say we will use PR to represent the predator population, and it is said here that the predator population is a function f of x. Okay, and it is said in the problem that x thou is the number of prey in the forest. Okay, which in turn is a function g of t. Okay, so x here, as said in the problem, is a function g of t. Now t here is the number of weeks that have elapsed since the end of the hunting season. Okay, now if so, f of x, PR or f of x was given to be equal to 1 over 48 x squared minus 2x. So this first given function is a function that expresses the predator population as a function of the number of prey in the forest. Now, how do we know the number of prey in a forest? It is now dependent on the time t, which is the number of weeks elapsed since the end of hunting season. And it was given that x, which is a function g of t, is equal to 40 plus 52. Now, what is being asked is the duration or the domain of t is in between 0 to 15 weeks. Okay. Now, do the following. So, we are to find a mathematical model expressing the predator population as a function of the number of weeks since the end of the hunting season. So, we need, in letter A, what is being asked is the predator population as a function. Let's say this function is h. Function h, the function of the number of weeks, and the number of weeks is represented by t. So, we are to model predator population as a function h of t. So we are now going to use h since we already have used f and g. So we have to use another letter or symbol to represent another function. What we have is predator population as a function of the number of prey, wherein in turn, the number of prey is dependent on the time or the number of weeks. But what is being asked is, what is the predator population for a given number of weeks? So, gusto niya, diretso na paghatag sa number of weeks, diretso makuha ang population. Kaya kung kanya itong gamiton, okay, pag given lang t, kailangan pa natukuhaon si x, then tsaka pa isubstitute si x diri para makuha si predator population. Okay, so what we are going to look for is this one. Okay, now, we know that predator population is function f of x. But we also know that x is equal to function g of t. Okay, so we are going to have, this will now become f of g of t. Okay, since g of t is equivalent to x. Okay, so that in this case, we will be able to have the predator of population as a function f of x, where x is function g of t. So with the help of this expression, we will be able to get predator population as a function h of t. Okay, so for f of g of t, isn't that a composite function? Okay, composite function. So that will be f composite g of t. Okay, so f of g of t, we have f, and g of t was given to be 4t plus 52. Okay, and then if f of x is 1 over 48x squared minus 2x, then if we have f of 4t plus 52, so we are going to perform evaluation of functions. So ang x diri sa original f of x, pulihan lang nato tanang x, o kaning nasa sulod diri na bag-o sa function f, which is 4t plus 52. So we are going to have 1 over 48x, or we will replace that with 4t plus 52 squared minus 2x, or we'll substitute it with 4t plus 52. Okay, so f of g of t, okay, which is equal to the predator population, is equal to 1 over 48. Ato lang i-simplify. So 4t plus 52 squared. So we are going to have 1 over 48. 4t squared, that's 16t squared. And then we have 4t times 52 times 2. 4 times 52 times 2. That is 416. So we have plus 416t. Okay, then 52 squared, that is 2,704. Then minus negative up. Then we have negative 2 times 40, that is 8 t, and then we have negative 2 times 52, that is 104. So we have minus t minus 104. Then we will distribute 1 over 48 in what's inside the parenthesis. So we have 16 over 48, that is 1/3. So we have t squared over 3. Then we have 416 divide 48. That's 26 over 3. So we have plus 26 over 3 times t, then plus 2,704 divided by 48, 169 over 3. Then we have minus 8t minus 104. Combine like terms, so we have 26 over 3t plus negative 8t. So 26 over 3 minus 8, 2/3. So we have t squared over 3, then plus 2/3 of t. Then we also have 169 over 3 minus 104. Negative 143 over 3. So therefore, predator population equals function h of t, which is further equal to t squared over 3 plus 2/3 of t minus 143 over 3. So this is now the function, the predator population as a function of t number of weeks. Okay, and then next question is find the predator population 11 weeks after the close of the hunting season. So at t equals 11 weeks, so our predator population is equal to, okay, we could just directly use this equation. So we have this, could type everything, t squared over 3 plus 2/3 t or x minus 143 over 3. We could press this one, calc, then when x is equal to 11 weeks, then we have equals, na zero siya, no? Okay. 11. Okay, so meaning there is no predator population in 11 weeks. Okay. Sorry, zero population, zero predator population. Okay, we will now proceed to the next problem. Next example for modeling functions. Let's have just an extra. Okay. Okay, so next is, you have here, a cardboard box manufacturer wishes to make open boxes from rectangular pieces of cardboard with dimensions. Okay, so we have cardboard dimension 10 inches by 17 inches. Okay, so this is our rectangular piece of cardboard. So this is 10 inches. This is 17 inches. 17 by 10 inches. Okay. Okay, so the cardboard manufacturer is going to form a box using this piece of cardboard. Okay. By how? By cutting equal squares from the four corners. Okay. So equal squares. Yan siya. And turning up the sides. So, pag nakat na dire, okay, ang maiwan, maging ganito na lang siya. Alright, that one. Okay, and then, dito, i-fold. Fold, fold, fold. Tapos, dito na sides, ito, and ito, iakyat. So that, makaporma siya ng box. Ganito. Yan. Okay. Now, equal dapat ito na squares ang cut. Okay. Now, we are to find a mathematical model expressing the volume of the box as a function of the length of the side of the square cut. Okay. Now, we have one of the quantities, the length of this square cut. Okay. So, meaning this is x, this is also x. So, x by x square ang cut. Okay. Now, the volume of the box should be expressed as a function of x, which is the length of side of square cut at the corners. Okay, so we are to find the volume of the box as a function of the length of sides of equal square cut. Now, if we are able to form the rectangular box, we know that the volume is, let's say you have length of the box times width of the box. Okay, length, width, and then height. Okay, so if we have the dimensions of the box, length, width, and height, therefore the volume of the box is equal to length times width times height. So if this box is formed from this cardboard, okay, therefore this will be the length L, this will be the width W, and then this will be the height. Okay? Kasi pag fold, ito na yung maging height, which is this one. Pag fold niya, ito yung height. Okay? Now, we know that we have to express the volume in terms of x. So, kailangan we get the length, the width, and the height in terms of x. So, since this is the height, we already know that this length here is the variable x. Okay? And then the length here, originally, the entire length of the cardboard without the cut, this is 10 inches. Right? And then, the width, okay, the original width of the cardboard is 17. Okay? And now, we have the width of the box, W. Then, this is x. And this is also the cut, x. So, therefore, we have 17 equals the width of the box minus 2x. Okay? So, therefore, the width of the box is equal to 17 minus 2x. Okay? And then, for the length, this is also x, this is also x. So, meaning here, this is x, this is also x. Okay? So, the length here, therefore, is equal to 10 inches minus x minus x. So, itong length of the box ang naiwan. 10 minus 2x. Now, volume is equal to the length, which is 10 minus 2x, times the width, which is, in terms of x, 17 minus 2x, and the height, which is also equal to x. So, this is now the function the volume as a function, the function volume as a function of x.